Okay, so if I were going to find the solution to each of these equations, what's the first thing I'm going to do with this guy? Take the square root of both sides, right? Okay, so when I take the square root, what's square root of 25? Okay, and it's going to be positive and negative 5. Okay. On number 2, we're going to do the same thing. We're going to take the square root of both sides. But instead of getting a whole number, we would just leave the square root of 7, right? Because if we took the square root of 7, we get a decimal. We don't want that. We're just going to leave it as that radical. One thing to mention, it's plus minus. That means that you have a positive version and a negative version. Some people always think that plus minus means one solution. No, that's 2 different solutions. Okay, sorry. Okay, plot twist. Now we got this cube, right? Okay, so instead of taking the square root of something, we are now going to take the cubic root of something. Okay, so fun fact, this 2 is the reason why we're taking the square root. This 3 is the reason why we're taking that cubic root. Okay, when we take the cubic root of 8, we're trying to think of a number that if we multiply itself 3 times, well, we would get 8. Okay, so what number can I multiply by itself 3 times to get 8? 2. Okay, so this is going to be 2. Now, there's not going to be a negative version, because if we had a negative version, that would give us negative 8, and that's a no-go. Okay, on the next one, we would take the cubic root again. Now, again, that's not going to give us a whole number, so we're just going to leave this guy underneath that radical. Nothing too crazy. One thing to keep in mind, there is a difference between 3 square root of 19 and the cubic root of 19. Okay, those are 2 different things, and you have to be careful on how you write this kind of stuff. Okay, you make sure that 3 is in the little cubby hole if it's supposed to be. Yep, it's called a cubby hole. I don't have a cool name for it. It's actually called the index, but we're not even gonna go there. All right, so Claire said, I know that 9 squared is 9 times 9. 9 to the first power equals 9, and 9 to the 0 power equals 1. I wonder what 9 to the 1/2 means. So first she graphed y equals 9 to the x. What would be an estimate for 9 to the 1/2 power? So looking at our graph, we have 0, 1. And over here we got 1, 9. If I'm looking for 1/2, it's going to be halfway between. What's that y value going to be roughly? 3. Okay. Now, Claire decided to use exponent rules to help her confirm her thinking. What did she get? So we got 9 to the 1/2 times 9 to the 1/2. We learned about this last week. What do we do with our exponents? Add them together. We're going to add 1/2 plus 1/2. When we're adding fractions, what do? We have the same denominator, so we just add the top. 1 plus 1 equals, so 2 divided by 2 is going to give me 1. So we're going to have 9 to the first power, which is just 9, right? So for this to be true, what must the value of 9 to the 1/2 be? So what number can I multiply itself to get 9? 3, right? So that means that 9 to the 1/2 power equals 3.
You're talking about you running from the back end?
All right, Diego saw Claire's work and said, now I'm wondering about 4 to the 1/2 power. So graphed, what would be an estimate for 4 to the 1/2 power? So looking at my little graph, I know this is hard to see. We got 0, 1, and we got 1, 4. So what would be halfway between? Halfway between 4 and 1, roughly.
How is that even possible? Do the math. 1/2?
2.
2.
Thank you. Okay, so we got 4 to the 1/2 power raised to the second. So we're going to use an exponent rule. What exponent rule are we going to use here? We got a power raised to a power. What are we going to do? Multiply. Power up.
Oh.
Yeah, power up. So 1/2 times 2 is going to give me, and remember, when we multiply fractions, we multiply straight across. So 1 times 2 is going to give me 2. 2 times 1 is going to give me 2. And that can simplify to 1. So this will be 4 to the first power. Now, for that to be true, what must the value of 4 to the 1/2 be? So basically, this is asking what number times itself would equal 4. So again, 4 to the 1/2 power equals 2. You take the square root of 4, you get 2. Ta-da. All right, so 4 to the 1/2 power is the same thing as taking the square root of 4. And that's going to give us 2. Okay, so this right here, this is the exponent way to write it. This is the radical way to write it. And then this is the simplified form. Okay, you know how mathematicians are excessive and they like to confuse people? Fun fact, there's a 2 chilling in this little cubby hole. We're just so lazy in the fact that we use this so frequently that we don't write it anymore. Okay, but we do for every other thing. This is what I need you to understand. X to the 1/2 power is the same thing as taking the square root of something. 3. So when we look at this first one, we've got 25 raised to the 1/2 power. So I can rewrite this as radical 25. Well, what's the square root of 25? 5. Fantastic. Ta-da! We're going to do the exact same thing on the next one. Square root of 15. Well, when we take the square root of 15, we can't simplify that anymore. So we're just going to leave that guy underneath the radical. So the answer is square root of 15. On the next one, we're going to have the square root of y. We can't simplify that anymore. So that's just going to give us the square root of y. Okay. The next one is a little tricky. Okay. So on the next one, we're going to write this where 8 is going to be underneath the radical. 3 is going to go in this little cubby hole. Now, what's the cubic root of 8? Somebody just said it. 2. We can do the same thing on the next one. Take the cubic root of 2. Well, that can't be simplified, so we're just going to leave that guy alone. Okay, so we got 64 raised to the 1/3 power. So we can rewrite this as the cubic root of 64. You can write it like that. Fun fact, your iPhone will actually do this for you. You just have to rotate it sideways, type 64, and then you're going to hit the button that looks like that. Okay, and then it'll take the cubic root when you type in that 3. Okay, you can do it that way. I personally like Desmos a little bit better because it'll do it for you as well. Or you could type it in this way for Desmos. What'd y'all come up with? You came up with 4. So let's think about it. Is 4 times 4 times 4 equal to 64? Yes. Okay. So when you take the square root of 64, you get what? 8. The cubic root of 64, you get 4. Cubic root. That means you're going to do it 3 times. Yeah. So circle each row of the 2 expressions that are equivalent. For instance, we got the square root of 7, which is the same thing as taking something and raising it to the 1/2 power. Okay, fun fact, I've got like a little diagram up on the board, but I'll also write it up here. You've got x raised to the exponent divided by the index. Okay, so this is it in exponential form. In radical form, you're going to have the index in the little cubby hole and the exponent inside. Okay, so when you're rewriting this stuff, that's what it's going to look like. Okay, so on this next one, we got 16 to the 1/2 power, which is the same thing as 4. Good. Okay, the next one, we got 4 to the 1/3 power, which is the same thing as what? Cubic root of 4. Good. Okay, then we got 27 raised to the 1/3. Everybody messes up on this one. It's 3. Good. Y'all didn't mess up. That's so great. Okay. The next one is what you're gonna see. Like, there's always one question on the final exam or on the SAT. They like to trip you up. So let me walk through it. So my exponential is gonna look like this guy. Okay. Now we know that with negative exponents, that means that you're going to do what with the fraction? Flip. Okay, so we're gonna take 9 and flip it. So that's gonna be 1/9. And now we're gonna raise that to the 1/2 power. So what's the square root of 9? 3. So this is going to be 1/3. Okay. The same thing is going to happen on the next one. So we got 3 to the negative 1/2 power. Again, we're going to flip the fraction. And then we're going to take the square root of the bottom. Ta-da. This one, we're trying to solve. So what did you say, Jade? Take the square root of both sides. So that means that we're going to have x equals positive and negative square root of 5. And now we're going to write it using exponents. So instead of saying square root, we're going to say to the 1/2 power. That's all we're doing. Taking the square root is the same thing as raising something to the 1/2 power. Now they want us to write the cubic root of 78 using exponents. Okay, so now here's our denominator, here's our numerator. So we're going to write 78 raised to the 1/3 power. That's it. Where I have some number and I have exponent divided by the index. When I rewrite this in radical form, I'm going to put index in the little cubby hole and the exponent inside. And we can go back and forth this way and that way. So for instance, right now we got 3 in the little cubby hole. That's going to be my denominator. We've got 1. Since there's nothing written there, we assume it's a 1. Then that's going to be my exponent or my numerator. So using exponent rules to explain why these expressions are equal to each other. So we've got a power to a power. So what are we going to do? Multiply. So we're going to multiply 1/3 times 2. Remember, when we multiply fractions, we're going to get 1 times 2, which is 2. 3 times 1, which is 3. So this is going to be 5 to the 2/3. On the next one, same thing. We have power raised to the power. So that's going to give me 2 times 1/3. So that's going to give me 2/3. So they gave me the same answer, right? How could we write 5 to the 2/3 using radicals, though? Okay, so going back to our little diagram that's up on the board. If our numerator is 2, that's going to go inside the radical. Our denominator is 3. Is going to go in the little cubby hole. I don't know why. Okay, so in our activating strategy, we saw that 5 to the 2/3 is the same thing as 5 to the 2nd raised to the 1/3, which is the same thing as 5 to the 1/3 raised to the 2nd. Using this thinking to rewrite the following two numbers in equivalent ways. So basically what they did here was they said 5 to the numerator raised to the denominator. And then the next one is to the denominator raised to the numerator. That's all they did. So we're going to do the same thing. We have 4 raised to the numerator raised to the denominator. And then we have 4 raised to the denominator raised to the numerator. Can you do the same thing on this next one? All right, and it's okay if you got these backwards, but as long as you have the same thing. So if I had 3 to the 4th power raised to the 1/5, and then 3 to the 1/5 raised to the 4th power. And it's okay if you have these flip-flop. It doesn't matter. Way, we can rewrite expressions that contain radicals. Okay, so using that radical notation, so we're going to have that 2 chilling underneath the radical. The 2 in the numerator is going to go underneath. The 3 is going to go in this little cubby hole. Ta-da! Okay. On this next one, we're going to rewrite using exponents. Okay, so we're going to go backwards, essentially. So we got this little 3 in the cubby hole. We got an 8 down here, and then we got 2 as our exponent. So we're going to have 8. We're going to raise it to the 2nd power. And that 3 is in that little cubby hole, so we're going to put that as our denominator. Can you try C? All right, so you should have gotten something like 9 raised to the 2/4, which you know how to simplify 2/4. That's just going to equal 1/2, which really you could simplify that down to 3. Okay. You definitely want to feel comfortable with going back and forth from radicals to exponential. That's definitely going to help you along the way. All right, so let's talk through a couple of these. All right, so 4 squared. If we simplify that, what is that going to give me? 16. So that's going to work. On the next one, over here to the right, if I took 12 and divided it by 3, that would give me 2 to the 4th power. And 2 to the 4th power is the same thing as 2 times 2 times 2 times 2, which would equal 16. Okay. On the next one, fun fact, if you have an index and an exponent that are the same, they cancel out. And so you're left with 16. That one also works. For E, we have 4 raised to the 9/3. Well, that simplifies to 4 to the 3rd power, which equals, I think it's 64. So that's not going to work. On the next one, we can rewrite this as 4 raised to the 8/4 power, which is the same thing as 4 to the 2nd. So it does work. And on the last one, we can rewrite this as 2 raised to the 20 divided by 5, which can be simplified to 2 to the 4th, which is going to give us 16. So everything buddy. Okay, so again, on this one, we're going to have 2 raised to the 5/3, and we're going to raise that to the 3rd power. Okay, so that's what it's asking us to do. So what's going to happen with these exponents? You're going to do, it's a power raised to a power, which is going to be multiplied. So that's going to be 5/3 times 3/1. So when I multiply, that's going to get me 15/3, which is going to simplify to 5. So this is 2 to the 5th power. Go ahead and take a second, try number 2. Write 2 to the 5/3 using radical notation. Okay, so when we write this in radical notation, we're going to put that little 3 in the little cubby hole. And we're going to put 2 underneath, 5 as our exponent. Okay, so on number 3, this is a weird question to ask, but sometimes this pops up on your final exam. Okay, so what 2 whole number powers of 2 does 2 to the 5/3 come between? Okay, so 2 to the 5/3 falls between what two numbers? If I took 5/3 and put it into decimal form, what is it roughly? 5/3. What is it? 1.66. Yeah. So it's more than one, and it's 2/3 of another one. So it's 1.66 repeating. So the numbers that it's in between is 2 to the first power and 2 to the second power. So what two numbers is it in between? 1 and 2. That is a really weird question, I know. So the powers are 1 and 2. It's kind of like, what is the exponent in between? I don't know why they would ask this question, but they can.